Hello everyone, myself Kunal Bhargav. In this video, I am going to solve third internal MCQ test paper of analysis and design of algorithm. In this question paper, we have 40 MCQs, so we will see the answers of that MCQs questions. So, first question: in Stressen's matrix multiplication, the number of multiplications needed to multiply two 2 into 2 matrices. So this algorithm involves computing six products of pair of 2 into 2 matrices and then adding and subtracting these products to obtain the final matrix product. Number of multiplication needed to multiply to 2 into 2 matrix is 6. So the correct answer is option B, that is 6. Now next question, the Huffman's code is a type of. So the answer is A, lossless compression algorithm, because Huffman's code is a type of codeless compression algorithm. It is used to compress data without losing any information. Now next question, in Critical algorithm, what is the time complexity of sorting the edges of the algorithm? So the most commonly used algorithm for sorting is quicksort, which has an average time complexity of 0 and log n. The time complexity of sorting the edges in Kruskal algorithm is 0 and log n. So the correct option is B, that is 0 and log n. Now next, fourth question, in Prism algorithm, what is the time complexity for finding the minimum weight edges from a vertex? So, if we use adjacency matrix to represent the graph, the time complexity of finding the maximum weight edge from a vertex in Prism algorithm is 0 in bracket n. That is option A. Now, next question. Uh, Fifth, depth first search (DFS) can be used to find. So DFS can be used to find the longest path between two nodes in a graph. By performing DFS and tracking the depth of each node, we can find longest path between two nodes. So the correct option is B, the longest path between two nodes in a graph. Now next question 6. Breadth first search BFS can be used to find. The BFS algorithm keeps tracks of visited nodes at the distance from the source node to each visited node, allowing it to find the shortest path between two nodes in the graph. So the correct answer is option A, the shortest path between two nodes in a graph. Now next question 7. Dynamic programming can be used to solve problems that exhibits. So dynamic programming is a technique that is used to solve optimization problem by breaking down into smaller subproblems and solve each subproblems only once. So the answer is option A, that is optimal structure and overlapping subproblems. Next question, eighth, the matrix chain multiplication problem can be solved using. So the answer is A, that is dynamic programming. The matrix chain multiplication problem involves finding most efficient way to multiply a chain of matrix bound by together. By using dynamic programming, we can solve matrix chain multiplication. So the answer is A. Then the next question, that is ninth. The longest common subsequence problem can be solved using. So this problem can be solved using dynamic programming. So the answer is option A, that is dynamic programming. Next, in Stressen's algorithm, the matrix to be multiplied are divided into. So the answer is B, that is two equal parts. The running time of Stressen's algorithm is based on divide and conquer strategy. It is a faster way to multiply two matrices. The running time of Stressen's algorithm is 0 n log 2 in bracket 7, which is approximately 0 in bracket n 2.81 n to the power 2.81. So the correct option is C. Now next question 12. Huffman's code are prefix codes, which means that. Uh, so the answer is A. That is, no code is prefixed to any other code. Now, 13th question. The minimum order of bits required to represent the symbols in a set of using Huffman's code. So the minimum number of bits is required to represent the symbol in a set using Huffman's code is less than number of symbols. That is option B. What is the time complexity of the standard matrix multiplications algorithm? So the answer is 0 in bracket n cube. That is option D. Question number 50. In Stressen's algorithm, what is the base case for the recursive algorithm? So the answer is question number option A. When the matrices are 1 into 1. Now next question number 16. The Huffman's code assigns shorter coder 2. Codes 2. So the answer of this question is A. Symbols with high probability. Now next question. In Kruskal's algorithm, how many times are the edges of the graph shorted? So the edges of graph shorted in Kruskal's algorithm is once, that is option A. Now next question number 18. Prim's algorithm can be used to find the newest spanning tree of. The Prim's algorithm is a greedy algorithm that can have cycle, that can directed graph can have cycle, so it is not possible to apply Prim's algorithm. So Prim's algorithm can be used to find a minimum spanning tree of undirected graph. So the answer is A, undirected graph. Now question number 18, 19. The time complexity of BFS is. So the time complexity of BFS is 0 in bracket n, that is option A. Now question number 20. The time complexity of DFS is. So the correct option is A, that is big O in bracket n. Now question number 21. That is, what is the time complexity of the dynamic programming approach for solving the longest common subsequence problem? So the answer is B, that is big O in bracket n cube. Now next question number 22. In the matrician multiplication problem, the number of matrices to be multiplied is. So the correct option is A, given as an input to the algorithm. Now question number 23. What is the time complexity of the dynamic programming approach for solving the matrix chain multiplication problem? So the correct answer is D, that is big O bracket and Q. Now next question number 24. That is, which of the following algorithm uses a greedy approaches? So the correct answer is option A, Kruskal's algorithm. Kruskal's algorithm uses a greedy approach. Now question number 25. The longest common subsequence problem can be used to solve. So the uh, longest common subsequence problem can be used to solve dynamics sequencing problem in DNA sequencing. It can be used to identify the similarities between two DNA sequences. So the correct option is B, that is DNA sequencing problem. Now question number 26. The running time of Stressen's algorithm is faster than the standard matrix multiplication algorithm for matrix of size. So the correct answer is option D, that is 4 into 4. Now next question number 24. In the Huffman's code, the average length of a code word is. So the answer is B, that is less than the number of symbol is it is, because the most frequently occurring symbol are assigned shorted code words, which reduces the overall average length of code words. Now next question number 28. What is the time complexity of the dynamic programming approaches to solve the matrix chain multiplication problem? And the correct answer is Option number B, that is big O in bracket N cube. Next question, what is the maximum number of sub-problems that need to be solved in a dynamic programming approach for the matrix chain multiplication problem for n matrices? And the correct option is C, that is n cube, n square. Now next question number 30. The dynamic programming approach is to solve the longest common subsequence problem. What is the recurrence relation used to calculate the length of the LCS? So the correct answer is first, that is LCS I and j equals to LCS of I minus 1, then j minus 1 plus 1 if x I is equals to y j. Now next question number 31. In the dynamic programming approach to solve the longest common subsequence problem, what is the time complexity to print the LCS? So the time complexity of longest common subsequence problem to solve the dynamic programming approach is big O n, that is option A. Now question number 32. What is the time complexity of the dynamic programming approach to solve the matrician multiplication problem for a given sequence of n matrices? So the time complexity of computing each entry in the table is 0 big O n, and there are big O n square entries in the table. Therefore the total time complexity of this approach is 0 big O in bracket n cube, that is option number B. Now next question number 33. What is the time complexity of the dynamic programming approach to solve the matrician multiplication problem for a given sequence of n matrix using memoization? So the time complexity of DP approach to solve the matrician multiplication problem for a given sequence of n matrix is big O in bracket 2 to the power n. So option D is correct. Now next question, that is question number 34. Which of the following algorithm can be used to solve the longest common subsequence problem? So the algorithm can be used to solve the longest common subsequence problem is dynamic programming. That is option number D. Now next question number 35. Which of the following algorithm can be used to solve the matrician multiplication problem? So all of the four mentioned algorithm can be used to solve the matrician multiplication problem. However, the most efficient and widely used algorithm for this problem is dynamic programming. That is option number D. Now next question. In the dynamic programming approach to solve the matrician multiplication problem, what is the minimum number of scalar multiplications required to multiply in n matrices? So in dynamic programming approach to solve the matrician multiplication problem, the minimum number of scalar multiplication required to multiply n matrices is m0 and n minus 1. That is option number B. Now next question number 37. In the dynamic programming approach to solve the matrician multiplication problem, what is the minimum number of scalar multiplications required to multiply a chain of length n minus 1? So this is also same as question number 36, and the answer is option B, that is this. Now next question number 38. Which of the following is not a subproblem of the dynamic programming approach to solve the longest common subsequence problem? So the correct option is option number D, that is LCS in bracket I plus 1 and j plus 1. Now next question number 39. The dynamic programming approach to solve the longest common subsequence problem has a time complexity of. The dynamic program approach to solve the longest common subsequence problem has a time complexity of option A 0 big O in bracket n cube n square, because DP approach involves constructing two-dimension table of size n plus 1 into m plus 1, where m and n are the length of two input sequence. The Time complexity of this in each all is big O 1, and there are n plus 1 into n plus 1 calls in total. So average time complexity of algorithm is 0 big O in bracket n square. Now next, last question, question number 40. What is the difference between Prim's algorithm and Kruskal algorithm for finding the minimum spanning tree of a graph? So the correct option is question number D. That is all of the above. That means Prim's algorithm starts with an arbitrary node and adds the shortest edge from the set of available edges, while Kruskal's algorithm starts with the shortest edge and adds edges in increasing order of their weight. And option B also, Prism algorithm uses a priority queue to select the next edge to add to the tree, while Kruskal's algorithm uses a disjoint set data structure to maintain the set of connected components. And also the option C, Prism algorithm always produces a connected tree, while Kruskal's algorithm may produce a forest of disconnected trees. So the option D, all of the above, is the correct option for this question. Thank you.